Hey everybody, it's John Broadwell, and I am currently working on a new revision of the Serial Wombat board that's going to come pre-assembled and ready to run, probably in a 1 kit. And the difference between this one and others is that it's more of a single purpose board. I think it'll do its job really well. I'm looking for your input, your design thoughts on this particular board and where I'm spending money and time and board space to see if it would fulfill a need that you have. The current Serial Wombat board is targeted towards a variety of applications, both UART and I2C control. It has pins on it for an FTDI cable. It also has a pins for an ESP01 8266 board, which is really, really good for Internet of Things applications. But I started designing that thing in 2020, and that feels a little bit dated now. And so I started looking to say, okay, what if I wanted a dedicated IoT board that used something really, really smart as the brains, but then used a Serial Wombat 18AB chip for powerful and capable real-time I/O. And the answer I came up with was, hey, what chip out there fulfills all those things? And the answer was the Seeduino Xiao family. Essentially, you can get that thing in a variety of different ESP32s. You can get it in a SAM21D. I'm pretty sure that they've got some Nordic chips that plug in as well. And so I'm creating a Serial Wombat 18AB board that will come pre-assembled that's designed to plug a Seeduino Xiao variant directly into it. And essentially the two I2C pins will feed into the SDA and SCL pins on the Serial Wombat chip, as well as being made available over these quick/STEM QT connectors. There are already pull-up resistors on the boards. I'm using 2K2s because that's what I've had good experiences with the Serial Wombat chip. There's a 0 ohm resistor here that you should be able to knock off pretty easily with a soldering iron if you don't want those pull-ups active. And that would be necessary if you've already had pull-ups somewhere else in your circuit, or if you wanted to hook up another Serial Wombat board that you had pull-ups on somewhere else. Basically, if you didn't want those to be active, you can disable them. There is a 3.3 to 5 volt to 3.3 volt LDO. The concept is you'll have a Seeduino Xiao up here using its USB connector to provide 5 volts into this board. That 5 volts will go through the LDO and out to the Serial Wombat chip. The Seeduino Xiao also has its own 3.3 volt, but it didn't seem right for me. You know, this chip, if we're pulling 300 milliamps, which is the maximum current pull to drive things off of this I/O, I didn't want to also drive that amount of current through the Seeduino Xiao's voltage regulator. And so we added our own voltage regulator. As long as they're close with the I2C pins, that should be fine, because both of these boards are going to be doing active pull downs with this 3.3 pull-up resistor or whatever it is. The SDA and SCL pins are not broken out separately. You can get to them through these up here and through the old remaining OLED connector, which is ground 3.3 volts clock and data on SCL. And the other pins, you can see the traces. I pulled the digital I/O pins from the Seeduino Xiao out to unpopulated header connectors. So if you wanted to be able to access those so that you could use both the Serial Wombat chip's I/O and the Seeduino Xiao's I/O, you'll be able to do that. You'll notice there's some new pins here. These holes right here actually tie into the ICD debug connectors for the chip, and that's designed primarily for my own use for debugging under MPLAB. There is still the only remaining through-hole connector is the address resistor. By default, that will continue to be open, so this will be address 0x6b. You could potentially short that to put it in UART mode. That doesn't make a lot of sense for this board. Or you could add additional 10K, 20K, or 30K pull-up resistors to put the board into I2C address 0x6C, D, or E. So anyway, that's kind of where I'm at right now. Give me your thoughts on this board, any changes you might make. Oh, one more thing I should add. On the boards, the Rev 6 that'll be coming out of the main Serial Wombat board, and on this board, I've put our waste, and these are 1206 resistors, a resistor pad that you can add a resistor there if you want. And all that does is provide a resistance path from 5 volts to ground. And you might say, well, why do you want to throw that current away? I actually use a fair number of USB batteries in my projects because they're easy to charge, they're easy to hook up, and just generally convenient. We know that the Seeduino Xiao will be connected up over USB most likely. So if you wanted to run that thing from a battery, sometimes those batteries shut off if you don't pull enough current to make them think that you're actually charging something. And so depending on the resistor you pick, and those won't be included, you could potentially get up to about a half a watt dumped through here, which in many cases should be enough to make the USB batteries recognize that there's a load there. Again, that's totally optional, but it's something I wanted, so I put it on there. So please leave me your feedback. I'd love to hear from you guys before I order some of these. Say, hey, this seems like a good idea, or I think you're off, or, you know, nobody's going to want these, or everybody's going to want these. Kind of tell me. The most expensive parts on this board are the headers, because right now I'm still having to pay a lot of money to get those hand soldered in. And then the most expensive components are the STEMMA QT quick connectors. Do you guys think those are worth it? Just let me know if you think somebody will actually use those. And also those got moved from down here to up there. Let me know if that would upset anything that you're currently doing, because I'm interested in how people are using this board. So anyway, shape of things to come, I hope. I'm pretty excited about this. Let me know what you think. I really, really would appreciate your feedback so that I can make something that you guys will enjoy using. The Serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Incorporated. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485. As well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.